All right, everyone, we are on our inverted pendulum controller lab. So you can see we have basically a potentiometer right here that's attached and measures essentially the angle of our pendulum. This is a pretty long, pretty difficult pendulum control, but we're going to see if we can do it. We have our motor, which is controlled over here. We have a fan that's just spinning because we just want to cool things down in case we are trying to tend to overheat. You can see basically on this one right here. Oops, let me see if I can find. Here you go. You can see our motor has basically a +5 or plus voltage, positive voltage, negative voltage. That's for the 12-volt power supply to plug into to excite it. You have a 5-volt and the ground you can see there. That's to excite essentially the encoder, and A and B are basically your encoder essentially controls as well. And so those are going to get plugged in there as well in order to measure essentially your position there. So, and we can actually kind of see this. This is a pretty complicated kind of diagram here. And you can see a lot of these are kind of coming out of here. So you can see that brown wire. That brown wire is going to connect. That's basically our positive. That is basically touching our motor A, that red wire that's coming out from our motor controller. The yellow wire is our ground. That's touching the ground, or not our ground, but our motor B. So that's going to essentially drive essentially the motor motion through our direction, pulse width modulation, and grounds, etc. as well. We're going to come back to that in a bit, but first things first, we have to break this down into a couple steps in terms of control. One, and probably the first and most important thing, we need to be able to control based on the angle that we read from this kind of potentiometer. Now you can see the potentiometer is connected, and we have 3 wires here. A white wire, a red wire, and a black wire. Now typically, as we've seen in our other labs, potentiometer outers are positive 5 volts, or positive and negative, or positive in your ground, and the middle wire is your wiper. Now be careful, you're going to have to measure with a multimeter to figure out which wire is your wiper. In this instance, the white wire here is actually our wiper. So be careful about that. So confirm that before you do that. But what we're going to do first, we are going to see, as you can see, my black wire here is connected to that ground kind of series on row 5. My red wire is connected to my positive 5 voltage on my Arduino, and you see the A0? The A0 is directly connected here to that white wire. So that's how we're going to read the voltage. We're going to have to calibrate it. So our calibration step, what we're going to do first, and we're going to do this over serial. So I'm going to run this code, and then I'm going to run Python, because I want to save some of these calibration factors. So we're going to hold basically the voltage this up. Oops. Let's try one more time. Oops. Doesn't like. Hold on just a second. You can see here, it doesn't like any serial plotter to be up and running. So for example, this is giving us our serial monitor. So nope. So we're not going to do verify calibration. So I'm going to run this code again. Kind of our calibration. We're going to run on here, and we are going to calibrate. Is there another serial monitor up? Nope. So see, we're holding it upright, so 0 degrees. And then I'm going to go and hold it to the right. And we're going to save essentially these voltages. And it's going to save it as a CSV. So I'm going to hold it here. Approximately 90 as best as I can. And we'll hold it the other direction. Just roughly. The key is just the 0 angle. And there we go. So we have our calibration factor. So what we're going to do now is we're going to go and plug those in. So let's go ahead and actually, we can do it right now. We have that saved, but what I'm going to do is I'm going to do verify calibration. So my verify calibration code here, we're just going to type in those values. So 3.9543, and then this is going to be 110.13, and then our bounds here are going to be 3.0693 and 4.7133. There we go. So we can verify and actually visualize this. So actually I'm going to turn on the serial monitor again. So we're going to verify this code, and we're going to make sure that we are, so you see here I'm kind of upright, and then we can see the angle here. So hopefully basically very close to 0. And this is great. 0 at balance, right? Great. And then if I go to the left, it should be going positive, which makes sense. And if I go to the right, you see negative here, and we're good to go. So we're measuring and we're verifying that works. So this is fantastic. So first step, complete. Now the next step that we have to do, that we might want to do in case we want to do some encoder work, is to verify that we could actually measure the position of our little cart here. So we're going to do that next, and then we're going to see if we can move left and right, and then we're going to get into some controls based on that angle. So see you then. All right, so what we're going to do right now is we are going to do, I'm going to zoom out a little bit, we're going to do our angle verification, or basically that the motion is working correctly based on essentially the angle that we're going in. So this is not a PID control, it's just basically, you know, if the angle is pointing in this direction, you know, basically move the cart that direction, or the pendulum. If it starts to fall, you know, over here, go that way. If it starts to fall over here, go this way. That's it. So probably a very, very simple, not really even any P or I or D or PID or PD, any type of control. So it's just that. So what we're going to do is we're going to run it, and then I'm going to try to basically, I'll prove that it's running in the right direction, and then we'll go ahead and start the PID control. So let's go ahead. I'm going to run. And it's not moving because we're at like 0. So, but if I start to give it a little bit of, see if we go this way, go this way. Good little controller. So you see, you get the picture. And I'm going to stop this now. There. There you go. So we stopped it, and that's pretty much it. So we're going in the right direction, so now let's do PID control. Okay, so we are going to test our PID controller right now. I'm going to give it a little blow. Pretty good. Look at that PID. Oops. There. And there you go. It's working, and now you can tune some parameters, and let's see how long you can keep it standing up. So enjoy the lab, and be ready to have some fun. Thanks. Bye.